Okay, so yeah, everyone, welcome to the first session of Coding Interview Crash Course, Introduction and Big O. Um, Basically, the whole point of this is we're trying to get everyone prepared for coding interviews, technical interviews um, within this one workshop series. And yeah, we want to see everyone succeed. So we're going to try to teach everyone from the ground up, from what coding interviews are to strategies on how to approach and tackle coding interviews to like the actual content, what's going to be asked. So I guess first, it's probably going to be useful if I explain what a coding interview or a technical interview is. So what is a technical interview? Basically, they're used by tech companies to recruit, and they're used during recruitment specifically to assess a software engineers or data scientists or interns or QA engineers coding skills. So they take many forms. Sometimes they give you an online assessment. So this is kind of like an asynchronous coding interview. Sometimes they give you a phone call and they want you to kind of code live. They'll ask you a question and they want you to write a program to solve some problem. Or sometimes they'll ask you to come in person or like a virtual on-site, so like through Zoom or through their own proprietary calling software. Um, and yeah, so like, but pretty much whenever you are looking for, whenever you're like during the recruitment process and you're being interviewed, usually technical companies um, will want to like do at least one or two like technical interviews. So I suspect that sort of everyone who wants to enter the CS industry is going to have to encounter some of these interviews. So yeah, like this is why you should be here. And if you're here, that's like you're already like a step up above everyone else. So I guess what's next important is what's asked during a technical interview. So what is usually asked during the technical interview is basically the interviewer will ask you to write a short program in a language of your choice in order to solve some kind of problem that they give you. And they'll often ask also follow-up questions about time-space complexity and how to improve your program. Now, if you don't know what these terms mean, don't worry about it. Alvin's going to go over it later on. But basically, these questions are designed to test your knowledge of data structures and algorithms. So you can see on the side here, the bubbles. Uh, these are some of basically like the most important courses at UCLA um, that pertain to your knowledge on data structures and algorithms. So specifically CS31, 32, 180, and like maybe a little bit of CS33. Um, we definitely think that it's going to be really useful to take CS31 and 32 before you try out like technical interviews. But if you haven't, don't worry. We're going to give you a head start. The bubble sizes are, yeah, I guess they are scaled in terms of importance. Like you should, CS32 is definitely the most important one. Although CS31 is a prereq to 32, so these are kind of like the same bubble. All right, so next, I guess it's important to talk about the process. So what does the whole recruitment cycle look like? So usually what happens is there's a couple of ways to begin the recruitment process. You can apply online. You could go to a career fair, and sometimes by just handing a recruiter your resume, you're kind of already in the application system. You can get referred to a company by existing employees or interns. Sometimes you can even cold email recruiters or cold email other employees in order to get you sort of your resume in their database and get your application in. So when you do start the recruitment process, usually the first like sync up, the first like basis of contact will be a recruiter. After which you'll receive anywhere from like an online assessment to like a phone screen. Sometimes you'll get to the on-site interview directly, but basically you'll get some combination of these before you get the offer. So that's kind of the area that we want to focus on is the online assessment, phone screen, and on-site interview part, like the pink bubbles and the pink arrows. And there are a lot of different workshops and resources available for the other stuff, like for actually applying. But we want to get you guys sharp and prepared for these pink bubbles, like these online assessments and technical interview parts. All right, so here's an aside. I will give you guys a little advice on how to answer behavioral questions and behavioral interviews because sometimes companies do have behavioral interviews. So this is coming straight from Cracking the Corner Interview, the book, which I heavily suggest you guys have a read if you haven't already. But oftentimes common questions will be like, they'll ask you to explain or just ask you to describe one of your projects in the context of one of these like common questions, like what was a challenge that you had to face during a project? What was a mistake that you made? Why did you enjoy working on a project? What were like some leadership qualities that you demonstrated, and etc. So it's always good to have a couple of projects that you're ready to talk about before any behavioral interview, and to like actually write down the answers to these common questions so that you have them prepared and that you're like able to just like talk about them like you know, you just worked on the project. And I think that kind of confidence and that kind of like I guess like preparedness for these kind of behavioral questions does come in really handy because oftentimes what divides sort of like a hire versus a no hire is whether or not they fit well, like whether they're a good culture fit, whether the recruiters or the interviewers like them. So how do you prepare for technical interviews? So basically it comes down to practice. We think that you should, the only way to like really improve and to um, get better at technical interviews is to practice. And the more you practice, the more your practice reflects the real thing, the better the practice is, right? So the two parts that we think technical interviews are made of are basically communication and problem solving. So you have to be able to communicate your solution well to the interviewer, and you have to be able to actually come up with a solution. And so the best way to actually practice is to like do mock interviews, give a mock interview to your friend, and like have your friend do a mock interview to you. Um, we will also tentatively be offering like mock interview resources later on in the quarter, but we definitely heavily suggest practice, practice, practice. So like, you know, if any of your friends are taking this, you know, workshop with you, definitely like I recommend we have some like suggested problems at the end of the slides to take some of those problems and give them to each other as mock interviews. And I think that when you start like practicing that, especially that communication part, the first step, which I think a lot of people don't practice as often, I think you're going to see a big improvement in your results and performance. All right, so I've been talking for a while. Here's a quick meme. So take a short break, but basically like it is kind of funny. Sometimes what they ask you during the interview has nothing to do with what the job is actually about, but definitely think being better to like having that like basis of problem solving and like building your problem solving skills is in the end like actually really useful for doing stuff like making a button bigger, just because oftentimes things are more complex than they seem. So you know, like making that button bigger might cause you know, some other like part of the app to need to be changed as well. So definitely problem solving is very important, even though sometimes there is a apparent disconnect. So I'll actually be throwing a poll at you guys. But I guess this poll is supposed to just give a little hint for who you guys are and like what your current like status is in terms of interviewing and like algorithms courses, just to give us a little like hint to how we should structure the rest of our workshops. But yeah, feel free to fill out a poll. We're gonna take probably like 3 minutes break, so we'll be back at 6:18. But take that time to fill out a poll, get a drink of water, relax and strap in.
Oh, man. Though, are you seeing like the poll in real time?
Wait, Alvin, what? I didn't hear you.
Are you seeing the answers in real time, or like what people are answering in real time?
Yeah, a little bit.
These the answers are actually kind of surprising me.
Yeah, they
I would just
are.
say that.
I'll release the poll results after we come back from the break, but they are pretty interesting. Oh, I should have put another poll in on whether or not like someone has is like currently interviewing or like is looking to interview. Maybe I'll put that as a poll next time. Yeah, Daniel, nice to see.
Good luck.
Got an OA due on Monday, Matthew. Nice. Good luck.
Anyone here have an OA for Citadel? I had one last week. It was very difficult.
Yeah, I think that was one of the harder ones. Um, it's
Yeah,
very like math focused, even though the recruiter like told me the next interview is going to be like a very system design and like practical focused. Oh, so an OA it stands for online assessment. So usually when you first apply to a company, you will they'll send you like an asynchronous coding test or like an asynchronous coding interview where they'll give you like a link to a website where they have a problem and they'll want you to write up a code solution to it and they'll kind of evaluate you based on your solution to that problem. And after that, they'll determine whether or not they want to do a live coding technical interview with you. So yeah, stuff like HackerRank or Codility. I know there's a new thing where it's called like, what is it called? But yeah, there's a bunch of platforms for that. Yeah, Code Signal, yeah, which is I think recently gone really popular. Um,
one person has not voted.
one person, that's fine. I think I'll end the poll and I'll share with everyone right now. Oh, share results. Let me know if you can see the results. I think this is pretty interesting that a lot of you guys are freshmen, but also have like some algorithms experience. Also, good to see that people are coming in from the Discord. Um, yeah, we've worked really hard to get like, Discord lively and have people talking on it. So great to see people coming from there.
You want me to continue?
Wait, real quick, there's a question from Max. What year, quarter do people typically start the internship search? Bill, do you want to take that?
I think everyone's experiences are different. I think that like oftentimes is like when you discover that internships exist, you kind of start. So for me, that was like like freshman fall quarter. But I think a good place to start is um, like when you're taking CS32, so like freshman winter quarter or spring quarter. Um, but honestly, like it's kind of like that saying, like the best time to start was yesterday, and the second best time to start is now. Um, no matter kind of what your experience level is, I think that it's always useful to um, be looking for like opportunities that match your experience level. I don't know. What do you think, Alvin?
Yeah, I think I think basically what you said about was right, but if you want to if you like to get through most, like, I guess 80% of the problems that you'll see, I'd say you'd want to at least have like CS32, like under your belt before you start doing like technical interviews, like at least the serious ones. What do you think?
Yeah, totally agree.
Should we keep going?
Yeah, I think this is good. We should continue. So the focus of this workshop, as I said before, is to give you guys the tools necessary to practice technical interviews, to actually practice using common interview problems. So we'll be going over problems during the second half of the workshop, and to improve your communication skills by having you explain your thought process to others. So definitely we want people engaged, we want people like, you know, asking questions and like suggesting solutions. We'll go over all of that when we do introduce the practice problems. But yeah, definitely we want you guys to succeed. And basically we want you guys to get to a state where you feel comfortable doing technical interviews, and you feel comfortable practicing for them. So let me talk a little bit about my own experience with technical interviews. So if you guys don't know what LeetCode is basically a platform where you can practice common interview problems. So if you Google it, you'll find it. But basically, the platform has like a bunch of problems that other people have seen in interviews in the past, and they have their own ID and old compiler and like evaluation system, and you can kind of like automatically do LeetCode problems on your own. This is kind of like a way to practice, and this is a really popular way to practice. And how many LeetCode problems you've done is kind of like a popular gauge, at least, of like how much you've prepared, at least. I think that it's not the best gauge, obviously, but I think this is useful to kind of share of like where I was at when I got the internships that I did. So right now I'm a junior CS student. So this is my junior fall quarter. During my freshman year, I had done around like 30 to 35 like LeetCode practice problems, so not too many. And I interviewed and got a position at InTouch Health, which is like a telehealth company in Santa Barbara. I think this was one of the only offers I got as well. So like this like freshman year was like I was pretty lucky as well. But don't like fret if you aren't able to secure an internship freshman quarter. Oftentimes people don't. And then during my sophomore year, I had done around, I think the day before I got my offer at Facebook, I had done around 70 LeetCode problems. So definitely like it gets easier sophomore year. So for all those freshmen worrying, don't worry about it. It gets much, much easier later on. So that year I did around 70 LeetCode problems, and this summer, past summer, I just returned from an internship at Facebook. And then junior year, right now I'm at around 130, 120. So I'm still like currently like, you know, interviewing as well. So I'm in the same spot as you guys, but this is kind of like a rough estimate of how much practice I put in and kind of the results I've gotten out of the practice. So this is like total. Yeah. So like right now, I think if you go to the next slide, yeah, it says like, this is like when I made the slides, I did 129 problems in total. In terms of like easy, medium, hard, for those of you that know what this is, we'll go over it. But I've done 47 easies, 67 mediums, and 15 hards. If you look at the chart, actually, you'll see that only 60% of my submissions were accepted. Like my acceptance rate is only like 60%, and that's totally fine because like oftentimes I'll come up with the wrong answer, or I like get like time limit exceeded, runtime error. Jonathan asked a great question. Is in this chart, is it I have exposure to this question, or if given this question right now, I could answer it perfectly? Definitely not the second option. Definitely like I couldn't probably answer it perfectly if I like saw it, but definitely like I've had exposure to it, And it's kind of like a rough estimate of how much I practiced, because I don't really like to like look at problems, like specific problems. I just want to like get in the practicing groove and like just be comfortable getting unknown problems. Like I rarely try to revisit problems that I do that I have solved already, but definitely like I just like to see new problems and like see how I tackle new problems. So a lot of people also have asked me whether or not you should be expected to like do leak code hards, because I know that's like a debate that's going on in the in the community. Just out of personal experience, this is kind of like a list of places that I've interviewed at or gotten offers at, and I've only gotten a leak code hard problem. Like I think now it's like 3 times or like 4 times, but definitely make sure you can tackle the easies first. Only after you feel comfortable with solving the easies, then move on to the mediums. And then once you're like really comfortable with the mediums, then you can try a couple of hards. Usually like, I think for the harder problems, okay, I just got a question from the chat. How long should the problems take? So if you're like practicing on your own, I think practice the easies until you feel comfortable solving them within like I think like 20 minutes or so. And then for mediums, practice until you're comfortable with solving those mediums in around like 30 minutes or so. And then hard, sometimes I think they have a lot of like variance in terms of how difficult they can be. Sometimes hards are like really difficult and they can take like an hour. Sometimes they're just like slightly trickier mediums where if you figure out kind of the trick, they're easy to implement and they take just as long as a medium. So don't worry too hard about how hard the harder questions take.
Yeah.
How bad was the?
I'd like to ask that. So it also depends on the like the subject, the type of problem you're like going for. If you're practicing things that you're like not great at, like for me, that's dynamic programming. That's just for me though. It would probably take a lot harder, even if it was like an easy, like a labeled easy dynamic programming problem. I'd probably like spend less time doing maybe a medium DFS or BFS type like graph problem if that was like my strength. So yeah, it's just for problems, it just really depends on like just like yeah, I guess your problem solving strengths and what you have practice with.
Yeah, for sure. I totally agree. Yeah, and I think someone asked how difficult was the technical interview for ACM ICPC. I think that's part of our banner. We don't have a technical interview, but yeah, it's pretty funny.
Yeah, don't be afraid. We are not doing any technical interviews.
Yeah. Okay. Another common question I get is, what language should I code in? And our honest answer is code with whatever you're most comfortable with. I think that most companies will accommodate for common languages, so like C++, Python, Java, etc. And some of them will even accommodate for stuff like Swift, JavaScript, Go. So definitely like pick whatever you're most comfortable with right now. This workshop will be taught in like C++. So like we'll try to provide solutions in C++ because mainly you'll be using C++ in like schoolwork, so in 31, 32, and because we also mainly use C++ in competitive programming. So it also kind of ties into that factor. But definitely like when you're actually doing technical interviews, do them in whatever you're most comfortable with. But yeah. C++.
I see the chat. I see the chat is very happy with that. It's an interesting thing to be very happy.
All right, yeah. So here's another meme break. Me doing something I'm perfectly capable of done before, but when someone decides to watch, yeah, press F.
Oh, are we doing a break or are you gonna keep going?
I think we're gonna keep going. After the warm up, we'll take another break.
Okay. All right, so let's get into the warm up. I don't know. Did we do introductions? I don't think we did like formal introductions. Hello, everyone.
Oh, you're right.
Bill, you want to introduce yourself first?
Yeah, I'm Bill. I'm a third year CS major, ICPC officer, and I'm going to be one of your co-leads for Interview Crash Course.
I'm Alvin. I'm everything Bill just said except my name is Alvin. Third year CS, ICPC officer, 1 year leads for interview track. All right, let's get into the warm-up problem. You guys are gonna help me do this because I am a little rusty. So here we go. Given an array of integers, write a program that moves the zeros to the start of the array while maintaining the relative order of the non-zero elements. So here we go. We have like our little input. So we have 12, 0, 1, 3, 0. And then by the end of like your program or function or however you're going to write it, you're going to move all the zeros to the beginning. And then you're maintaining the order of all the non-zero elements. So you see how 12, 1, and 3 are in that order. And then in the output, it's 12, 1, and 3, but all the zeros have moved to the beginning. All right. Oh, 1 sec. The Zoom thing is popping up, so it's kind of hard for me to switch tabs. All right. So does everyone understand the question?
So I think people are wondering whether or not like you're supposed to do these. So try you can try it yourself. Try to come up with a solution. It doesn't have to be like actual code, it could be like pseudocode, but this is like a warm-up problem. So I think
So
Alvin's gonna like kind of explain it right now. So
yeah. So wow, not all zeros in front, shuffle the array. Well, I mean, it's not, I mean, will that necessarily be right? Let's see. What if it was like 1, 0, 2? Oh boy. And then you shuffle it. And then you get 0, 2, 1. I know this is just a joke solution, but would it necessarily work? Bubble sort ignoring everything except zeros. These are all great. Oh man, but okay, everyone understands the problem, right? Let me know if you don't understand it.
Yeah. So in terms of
a couple questions, like, I said, do we need to do it in place? And another person said, could we make a second array?
You can.
So yeah, so like try to come up with like a solution that solves it just by like using whatever.
Yeah, use whatever.
Whatever you want. We'll like describe how to do it in better ways hopefully later on, but just like try to like come up with some solution and then try to like improve on your solution.
Oh man, so many so many like suggestions are coming through.
Right, so there are a couple of good questions about whether or not you're able to use like built-in functions and stuff. So usually when you are doing an interview, honestly, sometimes it depends on the complexity of the question itself. Sometimes people like to, or like interviewers want to see like specific implementations if like that's a large part of the like problem space. But like when you just need some kind of like common tool, like let's say sorting or like a common data structure to like as a tool to like help you solve the problem, then like it probably won't be necessary. A lot of times it's like using your own judgment of like, if I use this tool, will it like get rid of all of the like effort I need to do to actually solve the problem, or will there still be like steps I need to take? And I think I guess the last verdict is, if you're unsure, just ask your interviewer because they'll be glad to answer.
Yes. All right. So it seems like everyone's sort of gotten the gist of how we solve this problem. So first off, let's think of like just your trivial solution to this. So like, what's your first thought for solving this problem? For me, I guess that would be, For me, I was thinking we can make a second array. So we go through, and every time we see something that's not 0, we put it into an array, like at the end of the array. So we'd go through 0, that's like not non-zero. 12, that is non-zero, so we add it. 0, 3, 1. 3, 1. And then you see the size of this the new array, and then you like subtract that from the size of this array, and you get 2. So then we have 2 zeros out in front, and then we just copy everything from here into our final array. So we could do 12, 3, 1, like that. So do you guys think this would work for all possible solutions, or like all possible input cases? Yeah, okay. So notice how I end up using like the second, and depending on like the implementation, this third array. Is there any way that we could do, oh, wait, all right. Is there any way that we could do better? Maybe in time, like, or space complexity, do better? So maybe like using less operations or less memory, aka not using array? Is there any way? Can anyone think of a way to do that? A vector is like when I say like array, I kind of mean like vector. A vector is like a dynamic. Sorry, I just laughed. I just saw machine learning. Thought that was pretty funny. Okay, but I'm going to be using like array and vector interchangeably. A vector is a like dynamically sized array. Yeah, Edmund, you're correct. It's analogous to array list in Java. So just like dynamically sized array. Okay, someone has a very interesting idea. 2 pointers.
Okay, I did want to answer. Someone also had another idea. I think Stephen, you mentioned that if it's a dynamic array, we can pop zeros and just push them to the front. So I believe that like for vectors specifically, inserting something in the front actually takes O of n time, specifically with C++. So I think that would be an interesting idea if like it's possible to insert something into the front of the array like really quickly, like in constant time. But that won't work in this specific case. But that's a great idea.
Okay, so I'm gonna run with the solution that I thought of, and it looks like one other person has thought of. 2 pointers. Don't worry if you don't know exactly what this means right now, because 2 pointers is something we're going to be learning actually in the next workshop. But to give you an idea of what it is, let's say we have 2 pointers that are like 2 variables that are like pointed towards the end of the array. So let's say like we call it like I and J, and they both equal, let's say this is called like nums. Oh boy. So it's like nums.length minus 1. Nums. Sorry, it's a bit hard to write with a mouse. Lynn, you get the you get the idea. Okay. So it's like, all right, so they're both pointing to nums.length minus so the end of the array. And then how about, what if we loop one of them, we just keep going down the array, and every time we do, every time we see, we check if the, if one of the if like the pointer that we're using to iterate is pointing to something non-zero. Every time we do, we'd want to like place it where the other pointer is, at, and then iterate that other pointer. It sounds a bit confusing when I like say it out like that. So let's just run through an example. Oh man, is there a way that we can get different colors on? We can. I feel like that'd be too complicated though. Let's just go. All right, so we're going to be iterating backwards, actually. So we're going to start from here. All right. Is 1 non-zero? Yes. We're going to place it where our right pointer is at, which is just right here. So we place it. We iterate that right pointer. So it's pointing here now. And then this is going to, as we iterate, this is going to go to here. Okay, so is 3 non-zero? Yes, so we place it. It's just already there. And we iterate that. All right, so we're gonna move forward. Is 0 non-zero? No, so let's just keep going. Is 12 non-zero? Yes, it is. So we're gonna place 12 right here. And then what we're using to iterate is right here. So then we go to 0. Is 0 non-zero? No. Oh, and also when we place 12 here, we're going to iterate to right here. So we have iterated with one pointer going down the array like backwards. And now we just have this other pointer here. And what we can do with this other pointer is just add zeros going down. So then in the end, you have 0, 0, 12, 3, and 1. And this can all be done like in place without making a new array. So we could just act on this on the array we're given. So does everyone understand? Does everyone understand what we've done so far, or like what we did for this algorithm?
So I have a question about it. Is the reason that you would imagine the array was longer, you would leave that pointer there and not fill the 0 right away because you might come to other non-zero entries. And so basically that pointer just marks the place in the array where everything before it is a 0. Is that, or where that slot and everything before?
Yeah. So
okay.
The pointer that we have here, like the one that's not like actually iterating, is where we're going to place our next non-zero element. So oh boy. I wish I could I wish I could go back and like do explanate this. It's a bit hard drawing right here, but let's say we are, give me one sec. Okay, so let's say our the pointer where the next non-zero element is going to be right here. We would want to place 12 right here to we'd want to place 12 right here. Let's say our iterating pointer is right here. So then we check that 12 is non-zero. We want to place it right here where this is pointing at. And then we iterate we iterate this pointer. So I hope that cleared up things for people.
So you don't put any zeros in until you've finished moving all of the non-zero elements, correct?
Yeah, because
okay, cool.
Do you know why that we do that, right?
Yeah, because there isn't really a need to when you're doing extra operations when you're putting a 0 in if you're just going to move a non-zero in there. Is that right?
Yeah, because we're going through the entire like array backwards, and then like getting all the non-zero elements in like the place they need to be, and then we're filling up the rest of the array with just zeros. Do you switch to 12 in the 0? No, you're actually not doing any swapping, which is kind of weird and why this problem is a bit tricky. I think it'd be a little bit clearer if you just saw me write out code for this. So I guess let's just start it off. Okay, let's turn this into a function. And by the way, tell me if I'm making any like syntax. Yeah, tell me if I'm making any syntax errors because I'm a bit rusty in C++. Move. Oh, hello. Okay, move zeros.
I'm just going to work through the example input that someone showed off.
Oh yeah, thank you. Is it the 0512 one?
Yep, it's that one.
Right now, I'm making a for loop to loop backwards. P2 is going to be my second pointer, the pointer where I place the non-zero elements. Oh.
Alvin, can you close the chat on the bottom right so that because it's like covering up those? So.
Yeah. How's it now?
Yep, thank you.
All right. So I'm going to be iterating backwards. P1 minus minus.
Thanks, Bill. That helped.
Why use CSV when Zoom exists? Oh man.
Or is there a way to access the board where you're doing it? Like because I can't really see the Zoom screen is kind of small when I'm looking at the whiteboard that you're doing it on. Just
Oh yeah, Alvin, zoom out a bit because they can't see my arrows.
oh yeah, did you have a link to it, or can we like do we have to see it through the Zoom window?
Bill, should we share a link?
We will be sharing the end link. Like we'll be sharing the link after we're done with it, and we'll also be releasing a video, so you guys should get it as well.
I think he's just saying it's a little small on his screen, so he can't read and follow along.
Oh,
Yeah.
I see. Yeah, try to make the font as big as possible as well.
Maybe you could like in a bit like it's a bit too far out now. Like yeah, but maybe a bit. Yeah. Yeah. Okay. Thanks.
No problem. Oh man, why? This is very non-intuitive. Okay. So we're gonna check, we're using P1 to iterate backwards. We're gonna check if the array at index P1 is not equal to 0. We want to set the array at index P2 to equal like the index at like the array at index P1. And then and then P2 is going to be iterated this way. So, or like it's going to be decremented. So this is going to be the next place that we place a non-zero.
Oh, sorry, I did the wrong. It's the P1 and P2 I switched on the drawing.
Oh. Oh yeah, okay. And then after this, okay. Doesn't this move? Okay. That's what Edmund, that's what we want to do. We're moving all the non like zero elements towards the right, and then filling up the rest of the array with zeros.
Yeah, I think I get that part. I think my confusion is just that don't you also want to preserve the order of the non-zero elements though? So wouldn't that mess that up, or?
It actually is preserving it.
Oh, could you explain that a bit? I'm sorry, I'm a bit lost on that then.
Okay. Let's build.
So yeah, I can quickly go over the drawing. So basically the idea is P2, the pointer P2, points to where the next non-zero value should be. So whenever you're actually moving whenever you're actually moving a value from like P1 to P2, or setting a value, setting the value at P2 to be the value at P1, you're actually putting the value in the right place, right? So for example, like if you look at the second spot, like the second array that I've drawn, there's like two 12s. And the idea is because P2 points to the correct spot that the next value should be in, there's going to be like two 12s temporarily. But as soon as that 12 gets set to P2, P2 is going to increment. So it's going to move to the left one. And then that will be like the next spot for the next non-zero value to be put in.
Wait,
so
but
how
my confusion is, how is P2 there if you haven't iterated P2 yet, right? Because you just initialize P2 as nums.size -1, but when you're moving pointer 1 backwards through the length of the array, your P2 hasn't moved at all yet, right? So every time you find something that's not 0 and you replace the P2, you're still in the same spot. P2 is still in the same spot, right?
Yeah, we do iterate it. We iterate it every time we find a non-zero right here.
Yeah.
Yeah.
Oh, okay. Wait, but then the first time you find a non-zero, it just goes to the end though, doesn't it? Because it hasn't been iterated yet?
Yeah.
So the first time you find a non-zero, it'll iterate from the end to the front. So that's why it's P2 minus. So the first time like you encounter the value 1, for example, at the end, you will iterate to 3.
But I thought you just wanted to copy it to one space over, not to all the way to the right.
No, so the idea of the problem is that we want to place all of the zeros to the front of the array, right?
Yeah.
While maintaining the relative order.
Yeah.
So we don't want any zeros like in the rest of the array. We only want them all like spaced in the front.
Yeah, I know that you want the zeros there, but aren't you?
The code looks like it has a bug to me also, honestly. I've been trying to figure it out, but
hopefully,
because if you have P2 and P1 both initialized to the last element in the array, imagine you have 1 and 3. Well, the first time through, but you do, never mind, because you would skip that. So you, looking ahead, I think the for loop covers that. I think the for loop would cover that. My concern was if you had the 1 and then you came back around. Oh, Oh no, that's a separate for loop. Okay, so yeah, I think there might be a bug. Because when you go through and 1, it's not equal to a 0. You set P2 to nums P1. That doesn't matter. You're just basically setting 1 to 1. And then you iterate your P2. But then you go through and it's not, where do you iterate P1? Oh, P1 minus, no, it's right. It's right. Okay.
Yeah.
All right.
It looks a bit weird because it's not in like your little monospace fonts, but yeah, we iterate right here.
Yeah.
It's
cool.
Yeah. So oh, go ahead.
I'm really sorry if I'm like way too low IQ for this. It's just like,
no, don't worry about it.
My understanding of this is that like the first time my understanding of this is like the first time you pass, like, okay, wait. Each time you move pointer 1 to the left, does pointer 2 move as well to the left? Or no?
So
pointer 2 only moves to the left when you encounter when you encounter a non-zero element.
Okay, right. So I thought our goal was to copy like every time we find a non-zero element, we want to copy it to the index exactly to the right of it. Or am I wrong?
Not exactly to the right. Not exactly to the right. We want it to be where P2 is.
Which would be the end, though, the first time you go through.
It wouldn't always be at the end because every time we get a non-zero, we iterate it a little to the left. We iterate it 1 to the left.
Yeah. So basically,
I get it. Sorry, go ahead.
Oh, you got it? All right, cool.
I think so because the first non-zero element I find is the one I want to put most to the right because we're going in backwards order, correct?
Yep.
Okay. I think I get it now. Thank you. Sorry about all that.
Oh
yeah,
boy.
It's great that we want to work with you guys through the problem, because that's like what an interview would be like, right? Like the interviewer wants to work with you through the problem.
Oh boy. So it seemed like this is a pretty tough problem to start with, but don't worry. Next workshop we're gonna be practicing these type of problems a lot more. If you want to practice on your own, like before then, remember this is called a 2-pointer strategy because we're using like 2 indexes to store different types of information through the array. Oof, that was a lot, wasn't it?
All right, so there's a couple of problems. Alvin, I don't know if you want to address the like the most common problems that are being asked before we move on.
Well, actually, before we do, let's do a little big O review. Whoa.
Great. So yeah, so to Bryson, who asked about, wasn't this the Big O workshop? Well, here it is. So we're gonna go over Big O.
Okay, so we sort of like glossed over this when we were doing the warm-up problem, but it was pretty hard, and we were mostly like focused on understanding like the 2-pointer solution. But in general, you want to find the time and space complexity of every problem that you do. Like this, it basically should be secondhand. Like it should be like secondhand nature to you to find the Big O of like all the algorithms that you're going to end up solving, and your interviewers are going to be expecting that too. So, and it's something that you learn in like the middle of CS 3.2. But honestly, you could, if you don't have any like, if you're not familiar with Big O, you could learn it like at any time, just with a little bit of coding experience. But we're just going to go over like general rules right now. So the general rules, you want to find the expression for like the number of operations. That's like the number of operations that you do. And that like given like maybe an array of like size n, if you loop through the array, you're doing approximately n operations. If you're going to loop through it twice, that's 2n operations if the size of the array is n. And then your second step would be to drop non-dominant terms, which is, well, we'll get to the, if you look at the example, I'll like explain here, but let's go through and then number 3 is like ignoring coefficients. So let's say for an example, you have like 2 nested for loops and then 4 regular for loops, and then you do 4 operations at the end for just some generic algorithm. And for like your step 1, you find your expression to be 2n squared plus 4n equals 4. Then you want to drop all the non-dominant terms. So that's everything except for like your highest term. So that would, your highest term here would be 2n squared. So you end up dropping it for your big O. So that's equal to big O 2n squared. But then that's also equal to if you just ignore your coefficient. So that would be equal to on squared. So does anyone have any questions for about like big O as of right now? Oh man, oh man, Qua, what is this? This link has a lot of percents. All right, yeah, but does anyone have any questions on like the big O of what we've done right now? The example was a bit weird. Okay, does this mean that any program with a fixed number, even if it was huge, would still be O of 1? Yeah. It's, the example was O of n, right? Yes, it was. Maybe we do we have time to go back and look at like the runtime for our solution?
Yeah, I think that's a great like way to go through as an example, right? As like a live example.
Oh boy, okay. Okay, so we initialize a variable right here. So that's like one step. This for loop runs through the entire array. So that would be for, if our array was of size n, this would be approximately n. Or like there's a few operations in here, so maybe you could say that's like 2n or something. And then this is another for loop. It's like depending on where like P2 is at, would be like some number dependent on n. So let's just say it's a n operation. So we have like 1 plus 2n plus n. So that would be 3n plus 1, like approximately that many operations. Well, so yes, 3n plus 1, approximately 3n plus 1 operations. We want to drop all the non-dominant like terms. So for here, that would be 1. So that this would be O of 3 of n. And then in the end, we drop all coefficients. So that would be O of n. Can you guys hear that outside? There's a car alarm just went off. Okay, so does anyone have any questions for like what we did here? Is a for loop O of n and a for loop nested in a for loop O of n squared? If you're looping through an array, yes, because every like for loop that's looping through an array is like n operations, but if you're doing n operations like n times, that would be n squared. Right. Okay, so here we go. These are a lot of the typical like time complexities of like data structures. You don't have to memorize these all right now. We'll be going through all of these, a lot of like the important parts of this table, like as we go through the workshop. And then here we have it for array sorting.
Are we going to learn all of those? Like I know like red, black tree, like quite a few of those trees, but there were like quite a few on there, like AVL tree. I don't know what that is, or splay tree. Are we going to go over those at it?
We're going to go over the stuff that is going to be really important for the interview. So not necessarily everything down here. So
Okay.
no, you don't need to know about red-black, like implementation of red-black trees or like AVL trees. It's a bit too much for like our sake.
Cool.
What we are going to want to know is like the time complexities of like your most common data structures. So like an array, a stack, and then like your linked list, and then like the general one for a tree, but we'll be going over those soon. And the same thing can be said for sorting. You don't need to memorize all of these, especially like the ones that you've like never even heard of, like cube sort. So we'll let you know as we go through the workshop what is important to know and what isn't. Okay, so that was a lot of me talking. Bill, are you ready to step in again?
All right, yeah, cool. So basically, so I'm gonna go over quickly on like strategy of like how to approach a technical interview, because that's also something that I get asked often. Like, hey, I'm comfortable with working on my own problems, like online on LeetCode and stuff. But hey, like I don't know, what should I do? Like, what should I start saying during technical interviews, right? So here's a little outline. I think if you go to the slides, it's an article from like Google, like recruiting. So this is like specifically what they suggest for their interviewees to do. So there are generally 6 steps. So the first thing you should do is repeat the question in your own words, right? So this is kind of twofold. The first is to actually make sure that you read the question correctly. And I guess like reading the question should be step 0. But to make sure that you read the question correctly and that you understand the problem well enough to explain it to someone. And I think that's kind of the point where you actually fully understand what the problem is. So the second step should be to check assumptions and to ask clarifying questions. Oftentimes, this can be asking questions about the input. So like, what is the input bounded by? What is the output bounded by? Are there any like restrictions on the types of the inputs or the outputs? And so this is again twofold. One is to actually clarify to make sure that you understand the problem correctly and the input and output spaces correctly. And number 2 is to kind of communicate to the interviewer that you're able to ask questions. So I think that's also a really important skill to have as a software engineer. Third is to use real examples. So like I did before with the last problem, to think of a real example and kind of work through it step by step just to see what it looks like. Oftentimes, this will give you a good intuition of like what the solution should be. So like, let's say you don't know the solution, but you come up with a bunch of examples of what the input is and what the output is. Sometimes this can like clue you into what patterns and like what tools and what like data structures or algorithms you should use. And then number 4 would be to actually like think of a solution. So oftentimes like people suggest to either like talk out loud to like explain what you're currently thinking and have like that kind of stream of consciousness into like to your recruiter. Some people like advocate for just like not talking. I think both are fine. I would like ask my recruiter like, hey, do you mind if I like explain my thoughts out loud? But generally kind of spend some time thinking of a solution before you actually start writing your code. And only start writing your code after you've like explained a solution and its time and space complexity to a recruiter, to the interviewer, and you get like the green light to start writing code. And then step 5 is to actually write working code. And most interviewers expect you to write actual working code, and Google specifically does expect you to write working code. And so like you would write this code as if you're writing software for like production. Like you want to write high quality code, and you want to make sure that like it should be able to compile even if you're writing code like on a whiteboard or just like on like a blackboard or something. And then finally, what you can do now is you can take the real examples that you thought of in step 3 and then work through your code and text your code manually. And so this way you kind of like, again, it's twofold. Number 1, you confirm that your code works as expected and you like iron out any bugs that appear. And also like testing your code is super important as well in the industry. So those are kind of like the 6 steps that you should take during all technical interviews. And most technical interviews will look something like this. And I guess the most important thing I want you guys to keep in mind is that you don't start writing code until step 5. So there's like a ton of steps you need to take before starting writing code. And I think like the bulk of the interview is like the steps you take before writing code of like coming up with a solution, asking clarifying question, coming up with test cases and examples. And I think that's ultimately like almost more important than actually like working through the code. And obviously your code should be high quality and it should work, but like what you do before like starting writing your code and like actually thinking of a solution is oftentimes more important than when you start writing code.
Yes, it's very dangerous to, once you see a problem, just start writing code, especially if you don't really know what you're doing. That's pretty dangerous. Definitely something you do not want to do.
You'll probably do it on your first interview anyways, and then you won't get picked up. Speaking from firsthand experience.
Yeah, for sure. I've definitely had that happen as well. All right, so now that I have, this is kind of a short sellout moment, but we've explained a little bit of how to do technical interviews. I do want to shout out UP's Landing Your Dream Sweet Job Crushing the Interview workshop next week on Thursdays. That workshop, instead of going over technical interviews, it'll go over more generally about like the rest of the interview types. So stuff like higher reviews, OAs, behaviorals, like what you should expect in like kind of more non-technical interviews or like unique types of interviews like take-home assessments. This will also be taught by yours truly. So you'll see me there again if you want to show up. But yeah, check this one out. Definitely you don't want to miss it. This is also like a one-off event. This isn't a whole series, so definitely don't miss it. Next slide, I think, should show the link. Yeah, so go ahead to tinyurl/UP interview F20. And I think right now, before we head off to practice problems, we'll take another short 3-minute break. So we'll be back at 7:15.